Shahin is a front-end engineer and a blogger who writes about programming. I first found him through his articles on algorithms, and in particular, his articles on Big O notation. In this conversation, we talk about Big O notation in JavaScript, and we talk about time and space complexity. We also go over a common debate amongst developers, which is, will I ever use these computer science concepts in my real job? And if so, when? We also go over why it is beneficial to learn computer science as a self-taught developer and how to learn computer science if you're getting started. Hope you enjoy the episode. Thanks for being on the podcast.
Thanks for having me here, Madison.
I want to go back to the start of your journey and ask, how did you first hear about coding? How did you first get into it?
Well, since I was a kid, I always found computers fascinating, and I always loved to play games, Mario and all the NES games. But by the time when I was around 17 years old, I got to know one of my favorite music artists. He was a programmer, and he was living close to nature, having a mountain house. And he was able to support himself just by working remotely. At that age, that concept of freedom and flexibility, it's inspired me because I personally love to be free and having the flexibility, and I love the computers. So I tried to learn myself by the books, and it was about 2005, 2004, if I'm correct, yes. It was around 2005. And that time, we didn't have this much of content. Actually, today we have a lot of content, but I had to stick with the book. I didn't have any teacher, and I didn't have much English. So I had to stick with the book, and I learned some stuff. I managed to do some simple programs with Visual Basic. Then shortly after, life took unpredictable turns, and well, I had to save the day and work with mainly sales and marketing. But until end of 2017, I came to Sweden, and I decided to pick my old dream again. And since that time, I never looked back. At the end of 2018 September, I went into a boot camp that they teach full stack web development, and it was about a 6-month period course. That was my start, and since then I keep following my dream.
Yeah. So you went to a boot camp. Did you ever think more about should I go back to school, get a computer science degree?
Yes, actually, when I was searching ways to get into the software development, I searched a lot of options. I asked some friends of friends, and mostly I heard like, well, if you're going to do programming, you have to go to university. You need to go to 2 years. You need to go 4 years. I didn't get really the answer I was searching. But at that point, I had to do a critical thinking. If I didn't have the opportunity or time to invest 4 years before even coming into the job market. But thankfully, I got to know about this boot camp, and which was free, by the way. It was an initiative. I really appreciate all the time people give voluntarily to teach us. I always had this in my back of my mind that, it's a bit feeling. I think many self-taught developers at one point have this, I don't have computer science degree. Am I really, like the imposter syndrome?
Yeah, I think a lot of developers, even though I think there was like that Stack Overflow survey, and I believe it said over half of the developers who replied to the survey were self-taught. Pretty normal to be a self-taught or to not have a computer science degree. I mean, if over half of developers, at least from that survey, were self-taught, but I still think, many developers have a bit of a chip on their shoulder about not having the CS degree.
Exactly. And but for me, I guess for also many others, this was a like big issue I was thinking about all the time at the start. But after a while, when you get to know more about this field, reality is not like, okay, we can't say that university is useless, but in same time, even you study like computer science, the nature of these fields forces you to be a self-taught, self-learner. I don't think no one ever stops learning in this business.
Yeah, that is so true.
Yeah, it never ends. It's endless. It's an endless journey, and I like it because you have to learn something every day and get better.
So you wrote this post about surviving tutorial hell, and I get a lot of messages from people who talk about this where they're learning to code and they keep watching tutorials, but then they go and they open their text editor and they feel like they can't build anything. They just feel like they're stuck watching tutorials, and it's really hard to go and build stuff. Yeah, I'd love to hear more of your thoughts on like how do we get out of this tutorial hell where we're just stuck there?
Yeah, it's a great question because it's really survival. Because especially if you're a self-taught developer and trying to come into software development, it's overwhelming amount of content and courses and tutorials about everything. Tutorials are great unless you're stuck in tutorial hell. I remember when I was in the boot camp, we did the sample projects for practice. And we had a senior developer there. He had like 20 years experience. It was challenging because, like sometimes they throw people like you don't know how to swim, but when they throw you into water, you try to like do your best and suddenly you're swimming. So it was a bit like that position. And I got a task to do. And to be able to do that task, I needed to research. So I watched tutorials, I research, I read, then like it went 1 week. Then at the second week, my senior said, Shahin, there is something about software development. This is something you will pick up by time. You need to know when to stop searching and when you execute things. If you're spending too much time on searching, learning, reading documentation, if you feel like that, then it's time to do something about it. And if you are doing something that you feel like you're not going anywhere, then it's time to go back and read tutorials. I think it was one of the golden tips I still keep in my mind. And this, I think, applies to dealing with tutorials as well. So how did I deal was deciding about learning paths. So I went to a boot camp. It was specifically focused on the full stack web development. I saw a lot of tutorials because since they are there and they are easy to follow, like you just say, okay, I can learn like Python in 12 hours. Why not? I can write in my CV, but it doesn't work that way. So I think knowing your path is really important because this shiny object syndrome is always coming back. So keeping the path will make practical because let's say you want to be a web developer, you're learning. If you spend time on like learning maybe C++, C#, it's not a bad time spent. But if you do a critical thinking, does this going to help me finding my first job? I think choosing tutorials is about a bit practical. We need to think about the practical parts that for keeping things going. So sticking with your paths. And the second thing is, whenever you follow a tutorial, and you need to do something totally on your own, even it feels hard. Because if you don't do something on your own, you don't have the muscle memory of it. So it disappears. And it's really, really easy to go into another tutorial. Because why? It's simple. because
Yeah.
you have someone in the video that's holding your hand from start to the end, and you feel like you make a project. Yes, you follow along, but in fact, you didn't make the actual thought process and how can I build this from scratch? How can I put the folders in right order? So I think surviving is just based on two things: know your learning path and use tutorials in a way that do a tutorial, then do something on your own, and don't move on to the next shiny thing until you're feeling comfortable.
Yeah, absolutely. I remember reading somewhere, for every 1 hour of tutorials, try to code for 1 hour, even if you're just playing with the tutorial code.
Yeah, exactly. And also in the same time, we need tutorials. I mean, if you're stuck in tutorial hell, then you say, no, I'm done with tutorials. I'm not going to do tutorials anymore. I don't think that can help either, because at one point, all of us stuck at one point. And it's, I think, about knowing that point. When do I need tutorial, really? That's something comes by time, I believe.
Yeah, like when do you actually need one versus you're just taking one when it's not really necessary. Like it should be hopefully used to help solve a problem.
Exactly, that's my experience so far, and the methods I used really helped me so far.
You've written some really good posts about big O notation, data structures and algorithms, and I want to ask a little bit more about them. Data structures and algorithms are, most people listening probably know this already, but if not, they're pretty much these things that a lot of companies...
Scary.
They seem very scary at first. Yeah, well, they're still scary. Yeah, there are these things used, and we can get more into this later, but like how useful are these concepts in your day-to-day developer life? So you might be interviewing at a big company and you will, do a data structure and algorithm interview, but then a lot of people will say, well, I never actually use these. So I want to ask you a little bit more about that. You have these awesome posts on data structures and algorithms, and you have been teaching yourself computer science. Why did you first decide that you wanted to learn about these things?
Well, thanks. My story is, as I mentioned, every self-taught developer, this subject is every self-taught developer's in back of their mind. It's kind of feeling guilty whenever you don't learn these things. Myself, actually. And this thing about data structure and algorithms first came up in my one of my first posts, actually, where I described my first ever whiteboard interview. At that point, I realized this is something that serious and big companies are looking for. But I didn't know at that point, why are they looking for this ability, knowing these terms. By time I kept in the back of my mind, but I kept learning about like React, Redux, the front end to be able to do my day-to-day job. After one point, as I also mentioned in tutorials, as a programmer, you always want to learn something new, something more, something better. You want to go deeper. For a period, I wanted to have a boilerplate with Electron, and I spent about 2-3 months to make something reusable for myself. It took 3 months, then I wanted to start my blog, and I said I wanted to learn Gatsby. Okay. And for putting up a blog with Gatsby took me about 2 weeks using a template. At that point, I was questioning, like, what should I learn next? Then I put myself again into a critical thinking moment. I said, okay, Shahin, this is your job, and this is the profession you want to do for your life. When we look back, like 10 years ago, 15 years ago, like there was still today, there is jQuery, there is many different frameworks. They are coming and going. Like we have this latest and greatest things coming up all the time. So the tech stack 10 years ago asked for web developers is not same stack asked today. And it gets more and more complicated. But I saw a pattern, and this was about the data structures and algorithms, because knowing how to solve problems, knowing what data structures and algorithms being used, this ability can make you much easier to transform and go into the next new shiny thing. Because everything we do every day, everything is built based on these concepts. And the good feeling about this is when I know about data structures and algorithms, I know this is with me for life. I mean, it's not something that I learn a library's syntax today. I probably won't use that after 5 years. Who knows? But this is something can be with you whole life.
Yeah, so, that is true. There's a lot of new frameworks or libraries that come and go, but then there are these fundamental things like data structures and algorithms that you'll always need to understand.
Exactly, and also problem solving, because when I learn a new framework or a new library or anything like any NPM package, it's a syntactical sugar, actually. It's an abstraction. It's a boilerplate. It's ready-made code. It's like buying a pizza from a pizzeria. If you know how the pizza is made, which elements they use, then you have a better understanding. So it's similar to that, I believe. Having this concept and also problem-solving skills is a lot more valuable and something you can keep for your life.
Absolutely.
That's why I decided to go deeper into the computer science topics, because if I have a good problem-solving abilities, I can pick up a new language, pick up a new framework, pick up a new library a lot easier than people that don't have this base for data structures and algorithms.
Yeah, I want to get into that more. I think we should start with, big O notation. For someone who's listening, how would you describe what is big O notation?
Well, it's a complicated subject if you read Wikipedia or many articles, but let's keep it simple. So in the simplest terms, big O notation is a universal tool to see our functions and algorithms in a way that we can say how do they perform, which is better, how do they scale. So in essence, it's a mathematical notation, but you don't need to be a math wizard to be able to use it. So it's a universal tool to see and to balance, to analyze the code quality, actually.
Yeah, that makes sense. Yeah. Why do we need that?
Yes, but where do we use this in real life? Why do we need big O notation?
Why do we care?
Why do we care? Why do we even care? Because two things. First thing is we need something reliable to analyze efficiency of the code we write. And it should be something really universal, that it should not matter which language you use or which computer you have, because let's say we write a program and I have the latest greatest laptop, and you have the laptop from like 2005. And when we run the program, we are not going to have the same run times. Maybe you will open in 10 seconds, but in my computer, I can open it in 1 second. So how do we handle with this complexity? That's where big O notation comes in, because we can use it no matter what computer you have. For example, I'm a JavaScript developer, you're a C++ developer. We can talk in the same language I don't have to learn C++ syntax, or C developer don't have to learn my React syntax, JavaScript syntax. So it's a reliable tool that we can analyze and we can communicate across between developers.
Right. So someone is listening and they write a function, they write some code, and they want to know, like, how fast will this be? How fast will this operate? What's the correct word there? They want to know how fast their code is. And hopefully it's fast. Hopefully it does its job fast. How many seconds did it take? Right. But it will be faster or slower depending on what machine you're on, like you said. And so Big O is kind of a way to solve this problem of not knowing, like, how fast your code is going to be.
Exactly. It's focused on the behavior. That's why it's universal, because if we were focused on just the seconds, it will be incredible amount of complexity too. It's like, okay, this works on Dell, but this works 1.2 seconds on the Apple. Like, it will be incredibly complex. But we look at the behavior with the Big O, and we could, when we talk about Big O, it's about scalability, because every application starts from a little roots. Like, for example, let's say you have 100 users in such a little app. You're not going to experience big problems with scaling, even if you have a really bad optimized code. But as soon as you go to over thousands, millions, sometimes billions users or documents, whatever, there you will start to see big differences on how things operate, how the program operates. So this helps us to realize, okay, I write this code today, but even 1 year after or 5 years after from today, this function will still work, and this can scale.
Definitely. And to my understanding, Big O is measuring the worst case scenario. So your code could run differently on different machines. It could be faster, it could be slower. But Big O is saying, okay, what is the very worst case? What if we have tons and tons of inputs and huge amounts of data that's going into this function? And what's the worst it could possibly, I butchered that. What's the worst it could possibly run, I guess? How do I describe that? Worst case scenario.
Worst case scenario. Yeah, worst case scenario is something like the name, worst case scenario. Worst case scenario will be an example. Let's say we have an array of like 1,000 names, and we want to find the name in that array. So the worst case will be when we, for example, loop the array, it will check every element in that array until it finds the name we are looking for. In this case, worst case will be that name is at the end of the, like, it's the 1,000th element. That's the worst case. So worst case, in this case, it depends on the length of the array. So we just say, okay, worst case is depend on the input length. So we call this a linear time. So it's in Big O, we are really looking a pessimistic way to the things we write. So what can go worse? Because if we know the worst thing, we can optimize things.
Right. So say you write an algorithm and you want to know, okay, if there's going to be a huge amount of input into this, input size of a crazy large number, how will your algorithm actually perform in this worst case scenario? Is it actually going to do well given huge amounts of input size? Exactly.
And it's also, they are kind of data structures and algorithms are kind of like a married couple. Like they go hand in hand, really, because it also depends on your data structure. For example, if you have this list, let's go on the same example. We are looking for a name, and this name is on the first example we talked about. It was on the array, but how about if we had this name as an object property, do we need to iterate whole objects? No, we just keep the object key by the name, then we get it constantly. It's a constant time. So whenever you're dealing with a problem, it has two parts, because the data structure you pick plays a big role on the algorithms you operate with.
Mm-hmm. We also hear these terms, time complexity and space complexity, when we're talking about big O. How would you describe what time complexity is?
Yes, so time and space, today, if we look to like 60, 70 years ago, all first computers, they were like really big. People were working with papers and stuff. So since that time, we built a lot of abstractions upon abstractions upon abstractions. But if we really want to go deeper to the atomic part of this, it's all about time and space. Because when we run a function or an algorithm, we are actually using both time and space to run. What do I mean by this? Time is related to speed, and space is related to memory, actually. Speed is CPU, and memory is RAM. So whenever we use a functional or algorithm, we are using both these elements, time and space. And there is always a balance between whenever we write a function, it has a specific time and space complexity. Even we don't think about it, it's always there.
Mm-hmm. And generally speaking, as a developer, you want your code obviously to run as fast as possible, and you want it to take up as little memory as possible as well.
Yes, that's actually a perfect world. It's very hard to keep everything perfect, like everything constant. Unfortunately, we don't have that world. But of course, it's for a JavaScript developer, we have a pretty good amount of memory actually in the browser, like gigabytes of memory. You can store billions of items in an array. So as a JavaScript developer, we don't have that really tight problem with the memory, actually, because if you think about small devices where memory is really important. So the main point I try to make is the time and space complexity is situational. You want to balance them based on the platform or the thing you're dealing with. So, and it always goes like this. If you wanted something faster, you need to sacrifice some memory. If you want to use very little memory, then you need to sacrifice some time for it. So in the case with JavaScript, we usually want things to go fast as possible. But of course, we need to also watch the memory as well, because I don't know if it happened to you, but when I was studying the loops, I always got an error with the infinite loop that the call stack exceeded.
Mm-hmm. Yeah, definitely. Seen that too many times.
Yeah. Yeah, while loops, for loops. Actually, it's a memory problem. Even we have good amount of memory, when you call something infinitely. So the point is, we have good amounts, we still have limitations. We need to watch out why things happen.
Mm-hmm.
So it's all about balancing between time and space, and for JavaScript specific, we need to watch out. We will try to keep the time as good as possible.
Right. I'd love to talk more about JavaScript in particular. So you've kind of mentioned this already, but when we think about space complexity, why don't we have to worry about space complexity as much when we're using JavaScript? You touched on this a little already, but I'd love to talk more about it.
Sure. Great question. Well, in JavaScript, it's language specific. So in languages like C++ or C, you do the memory allocation and management yourself. Like you define a variable, you make a space for it, and you need to like release the space you used. But in JavaScript, this is handled under the hood. It is still an issue, but we have something called the garbage collector. So when the engine reads our code, it goes through. When you're not using the variable anymore, it's garbage collects. It's when you define a variable, it opens a space in the memory. When it's used and has no use anymore, garbage collector marks that and that sweeps that under. So it happens automatically and we don't see it.
Okay, so JavaScript has this garbage collector. And then is it that other languages don't have this?
Some languages have, don't have this. And also this garbage collector is working well, but still it's not perfect. Nothing is perfect, of course. For example, have you ever heard about memory leak problem?
I'm not sure. The memory leak problem?
Yeah, so it's something like this. When you use a like set timeout and forgot to clear the timeout, so it stays in the memory. Or another example will be if you're using vanilla JavaScript and you have like 3 pages and you have event listeners. So you go to page B, you have an event listener, you go back to page A, there's also an event listener. So each time, if you don't take care of those things you need to take care of yourself. So those keeps adding up in the memory, and it will cause a memory leak.
Okay, that makes sense. So when it comes to JavaScript, we don't have to worry about space complexity as much because we pretty much have this kind of behind the scenes garbage collector kind of helping us do our job and only storing things in memory when we really need them to be stored and then removing them when we don't. Does that sound right?
Yes, it does, because majority of the things are handled, but when it comes to memory, it's just good to keep in mind that things that can cause memory leak, because we want to help the garbage collector to work good as it should. And there are some blind spots that we just need to keep in mind when it comes to space complexity. And of course, the function calls. If you do an infinite loop, you will go out of memory, because even when you're calling a function, you're using memory. We're using call stack. So if the name, everyone knows, Stack Overflow, that's the problem. That's the error we get when we reach the limit, and that's the error we get because there is no place in memory to keep in touch that, okay, what's going to happen next? So we are full there. So with space complexity, we don't have to worry too much, but it's always good to keep in mind as a general thing that we don't sabotage the memory and garbage collector in a way we write the code.
Yeah, that's well explained. I think that makes sense to me. I want to go back to time complexity a little more. So people who are listening might have heard of things like constant time or linear time. Could you go over maybe starting with what is constant time and how does it relate to big O notation?
Sure. So most often as a JavaScript developer, you will be dealing with constant time, linear time, and sometimes quadratic time. I will try to give an analogy on those ones to make it understandable as possible. So let's say we have a bakery shop and we have 10 cakes on the display, and we got a customer, and a customer wants the cake at the number 4, the 4th cake. So the time to take that cake is always going to be the same. Even we have 100 cakes, it's still at the number 4. So it doesn't matter. So the constant means it doesn't matter how many input you have, it's always takes same amount of time. Make sense?
Yeah, that totally makes sense. Yeah. So if you have a bunch of data coming into your algorithm, no matter how much data, whether it's just one data point or, the input size is 1,000, the algorithm is always going to run for the exact same amount of time, which is good. It's consistent. You feel very confident knowing, okay, the algorithm will always run no matter how big my input size is, it's always going to run for X amount of time.
Exactly. That's the ideal. That's whenever you see constant time O and 1, that's the best of the best. That's the number one. That's the best thing when it comes to scalability, because it doesn't scale at all. It's constant. So its scalability is out of the door. We don't have that problem. And when do you have constant time? Practically examples will be, let's say you have an array, then you just want to get the element 4, like you write 4 in the brackets. That's constant time. Same thing with the object properties. You have an object with properties name and surname. You just write object dot surname, then you get the surname. This is a constant time in the code. So when it comes to linear time is, whenever I talk about linear time, I like to say, think about the loops. It's very easy to understand and straightforward also. Linear time is, let's go on with the bakery. We are going to open the shop. It's morning. We just baked the cookies. So we need to put the cookies on display. So you put 1, 2, 3, 4, 5. So if you have 10 cookies, it will be 10 times of the time that you put one cookie. So if you have 100, it will be, let's say if it's 5 seconds, 10 will be 50 seconds. So 100 will be 500. So linear goes like this. So it's always depend on the length of the array. So
yeah, makes sense.
So it's same thing with the looping an array. Actually, when you're searching something in the array, or when you're finding something, or when you're everything that needs to iterate every item at once, it's linear time in the code.
So it's pretty much, I'm going to kind of go over each item every time just once.
Yes, just once. Do something with the element or find something. So it's always depends on the length of the input, and it's something reasonable.
So if you're writing, for example, just a for loop, and then for each element in that for loop, you're just going over it, looping over it once, which is good.
Exactly.
Or maybe it's too generalizing to say that's good, but
there is better things, but it's reasonable. It's reasonable.
It's not great to do a nested loop because you're going over everything, every item.
Yeah, yeah.
Would you describe it as twice, I guess? You're going over every item twice?
Yeah, it's like a matrix. You can think about, like, if you're making a square, let's say you want to print square on the screen. You want to 5 of 5 square with 5 on each side. You can use a nested loop to do that. So it's always number times number. And I can say nested loop, it's a square of a number, and you need to watch out, because if you have even 1,000 items, you're going to iterate 1 million times, and it's really bad.
There's also quadratic time. Could you go over what is quadratic time?
Sure. So quadratic time, it's actually the good old nested loops. But by meaning nested loops, it's the loop with an inner loop looping through the same array. So in other words, we call this square of a number. What is square of a number? As a reminder, it's number multiplied by itself. Like if it's 5 items, 5 times 5, 25. So if it's 10, 10 times 10, 100. But this is a common beginner mistake using something with nested loops. it is an advice to not use nested loops regarding time complexity, because even you have 1,000 items, it becomes 1,000 times 1,000, which is a million iterations. So if you ever have go through 100,000 items, you're going to have astronomic complexity very quickly.
Yeah, that makes sense. So it's not good to use. You want to avoid it if you can.
Yes, and there are different ways to improve. If you really need to use the nested loop, for example, you can use an object as a lookup table, because reaching an object as a lookup to look up to an element is, constant time. So you can, when you learn this basics, at least the things that you use daily, you can really improve your daily problems, daily coding problems.
Mm-hmm. Yeah, that makes sense. One thing we could probably touch on is maybe, I guess we already said this because we did talk about the call stack,
Mm-hmm.
but maybe we could talk about, so data structures and algorithms,
Yes.
where are they used maybe, or what are some real examples of data structures and algorithms used, not just in technical interviews?
Yeah, like daily operations, you mean, like the practical daily job, where do we use the data structures? Because
yeah, maybe I could get into, so a lot of people say that, how do I say it? A lot of people say that with data structures and algorithms, you have to learn them if you want to pass the interview at a lot of these big tech companies. But people would argue that we don't really use them in our day-to-day jobs. And so they're not really the most useful thing. And so that's why a lot of people argue that the interview process for some of these companies that do test on those things is kind of a broken process. What are your thoughts on that? And how much do you feel like these concepts are used in the day-to-day?
Well, to be honest, I'm not when I work, of course, I'm not making a binary tree from start and putting linked lists in my job, of course. For an overview, this knowledge helps you to become a better problem solver, because for a JavaScript developer, daily data structures you use is always arrays and objects. But for some scenarios, you may use, for example, stacks. Let's say you have a mobile view, that you have a model that you want to put stack over stack over stack to show something. So in those parts, you can have a use of this. But in the interviews, I believe this being tough on the interviews is related to if the company, I think it's mostly about the problem solving part, because personally, when I went to an interview with a big company, I faced this. But when I went to an interview with a startup or more small, mid-sized companies, this interview process changes. But also, of course, it will be weird if I go to a startup or a really small company that doesn't have much to do with scaling, and they try to put me to solve a red-black tree data structure. It will be awkward. But overall, I think knowing this concepts has a use. I use it every day. The things I use every day is arrays and objects. So sometimes even stacks. So whenever I'm solving a problem, this knowledge helps me to how to structure things, how to make an algorithm, how to solve this problem, how to use a different approach. So I believe it's not necessary. I believe we can't say that this is not necessary to learn. So this is my overview.
Yeah, and I started to see it more once I worked at a company where we just have so many users. And so you do start to think more about performance, and you start to think about how useful it is to know, okay, how fast is my algorithm going to be once we have all of these different users, and how, how much is that going to slow down the experience in the UI?
Exactly. And if you're using, for example, wrong algorithm, let's say you're doing charts, you need to render charts and you need to go through a lot of like data, for example. And if you're using like nested loops to like somehow shape the data you want to display, it can cause some flickering on the screen, actually. So those little things can help to figure out how to approach with the best solution. But mainly it's practically, like I mentioned earlier, like learning, going through tutorials. This is something I personally look practical, because I look at my daily job and I look at the problems I solve daily. Okay, what data structures and algorithms are going to help me in my day-to-day job, and which ones are going to help me if I want to go through one step forward in my career. I believe this will be the best priority to put for personal development, because it's practical and you will see results of it in your career.
Yeah, absolutely. So for someone who is just learning how to code, would you recommend they start learning about data structures and algorithms right away? Or would you recommend they, wait a bit and first learn just JavaScript on its own?
Well, from my experience, actually, I started a little bit late. It's not too late, but it's still, I feel like I could have started earlier to learn data structures and algorithms. So if you're a developer, knowing JavaScript for a while, even working in a company, you are using them without knowing. Whenever you write a code to do something, you are actually using data structures and algorithms, because data structure plus algorithm is a program. But for a starter, my advice will be to get at least comfortable with the basics of a language. What do I mean by that is to, for example, control flow, like if, else, loops, what is a function, knowing what is an array on object, like really the basic JavaScript. Then if you know the basics, it will be wise to pick up early as possible, because this gives you a different view on whenever you look to a problem or whenever you look to a framework. This gives you a deep knowledge to look at the things in a different way, in a different light.
Yeah, absolutely.
And also, there is something that some people may ask, okay, now we use a lot of abstractions. For example, I'm building a React app. I use a ton of libraries, and I use like built-in methods and some ready-made methods. How am I going to analyze big O in this case? So this was a question I asked myself also when I was learning this, and answer is just single. You need to go deeper. So if you remember my blog post, I always used like the typical, I try to keep it as simple as possible with like for loops, universal control flow of elements. I didn't use like dot map, for example. If you talk about JavaScript, I didn't use dot map, dot filter, and most developers use those actually. But to figure out, to calculate the complexity with built-in methods, you need to figure out how are they implemented under the hood. For example, map, filter, reduce, they are linear time. So when you try to analyze your complexity, you just need to keep in mind that they are linear. Or if you are using a method from another library, then you need to take out their repository to figure out what is the time complexity.
Yeah, I think those are great examples of where we actually are using data structures and algorithms under the hood. Some people would say, well, we never use these, but we do in fact use them. They're just kind of under the hood and abstracted away from us.
Always. They are always somewhere under the hood, even we don't really see it. And even for JavaScript, for web development, they still play a role. But for a practical viewpoint, knowing your constraints and knowing the problems you solve is really helpful as a developer. Because we don't use too many data structures in JavaScript in day-to-day, unless you're manipulating like DOM tree, for example. DOM tree is a tree data structure. So there are a lot of data structures under the hood, but if we get better at the things we use daily, that's a great start, I believe.
Absolutely. I think this is a good place to wrap up. Thanks so much for joining me. Really appreciate your time.
Thank you. Thank you.
For anyone who's listening and they want to connect with you, can you tell us where can we go to follow you or find you on the internet?
You can visit my blog, sahinarslan.tech, or you can also follow me on Twitter.